Good morning. Today I thought I would film our math in our classroom. Sadly though, as I fill it, you can see all of your chairs are still up on your desk and the chairs are empty, which makes me very sad. So I will be teaching to an empty classroom, but you guys will be watching from your virtual classroom at home. All right, today we are going to be talking about quadrilaterals. We've talked about polygons, we've talked about triangles, and today we're going to focus on quadrilaterals. So let's take a look at our notebook notes first. This image is in your book as well if you want to follow along in your math book on page 334. This is in your math book on page 334. When we take a look at quadrilaterals, a quadrilateral means that it has four sides. There's four sides on a quadrilateral. That's what the word quad means. Quad means four. So any four-sided shape is called a quadrilateral because it has four sides. So we have different types of quadrilaterals, so they have special names. If you look at the very first picture there, that's a trapezoid. And a trapezoid is a quadrilateral because it has four sides, but it only has one pair of parallel sides. So on the quadrilateral, we can see right here and right here, these are parallel, these are not. Remember, we know parallel lines run side by side the exact same distance apart the whole time. So in a quadrilateral trapezoid, what makes it a trapezoid is that it only has one pair of sides that are a parallel. The other sides, not parallel. The next one is a parallelogram, and a parallelogram is a quadrilateral with two pairs of parallel congruent sides. We talked about congruent the other day, meaning exactly the same. So we know with a parallelogram, these sides are parallel and they're also congruent. So I could pick up this side, set it right on this side, and it'd be the exact same. These sides are parallel, same thing. I know that this side, I can pick up this line, lay it right on this one, and they're going to be congruent. Because a parallelogram, both sets of sides are parallel and congruent. And finally, when we look at the other top one, a rectangle is a parallelogram. Rectangle can also be called a parallelogram because both sets of sides are parallel and congruent, and it has four right angles though. So a parallelogram can't be called a rectangle because it doesn't have four right angles. We can see that. But a rectangle can be called a parallelogram and a rectangle as well. A rectangle's definition is a parallelogram with four right angles. Parallelogram means two pairs of congruent sides, which we have, and four right angles, which we have. So a rectangle can be called both a rectangle and a parallelogram with four right angles. Now, if we take a look at the second row here, we have a square. And we know that a square is a parallelogram that has four congruent sides. All four sides are the exact same, and four right angles. So all four sides are congruent, and they have four right angles. Okay, so square can also be called a parallelogram because it has four congruent sides, but a parallelogram can't be called a square because, again, it doesn't have four right angles. If we go back up here and look at the definition of a rectangle, this is kind of confusing. If we look at the definition of a rectangle is a parallelogram with four right angles. Okay, so is a square a parallelogram with four right angles? Yes. So we could also call a square a rectangle because it fits it in the definition. But if we look here, a square is a parallelogram with four congruent sides. Does this have four congruent sides? Nope. So this could never be called a square. A square could be called a rectangle because by definition it fits. Parallelogram with four right angles. Parallelogram, four right angles. But a rectangle can never be called a square because it doesn't have four congruent sides. Weird. Sometimes they can be classified that. We always usually call them what they are: square, rectangle, parallelogram, trapezoid. But today in your assignment, they want you to name the parallelograms in different ways. All right, rhombus. If you take a look at the rhombus is a parallelogram with 4 congruent sides. There are no right angles in this one. The definition of a rhombus, it's a parallelogram, which we know means it has 2 sets of parallel sides and 4 congruent sides. So again, boom, 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 boom. All 4 sides are the exact same. No right angles though. No right angles. So if we look at the definition of a rhombus is a parallelogram with 4 congruent sides. Could we call a rectangle a rhombus? Well, a rectangle is a parallelogram, but it doesn't have 4 congruent sides, so that would be a no. Could we call a square a rhombus? It's a parallelogram, 4 congruent sides, 4 right angles. 4 congruent sides, parallelogram. So this couldn't be called a square, no right angles. It couldn't be called a rectangle because we don't have 4 congruent sides. But it is a parallelogram also because it has 2 pairs of congruent sides. Now, if you take a look at just the bottom 2 here, they're talking about the diagonal of a polygon. And the diagonal of a polygon is a line segment that joins 2 vertices of the polygon, but is not a side. So if we take a look here, this is a diagonal because it's connecting the vertex of A to the vertex of C, and that is not a side. This couldn't work because this is a side. We could also have one right here. We could connect the vertex at D to the vertex at D. They do a great job. And that would be called diagonal. It's not a side. Same thing here. If you take a look here, it's connecting the vertex at P to the vertex at R. It's cutting through the figure. It's not one of the sides of the figure. It's cutting through the figure. P to S is another diagonal. I could do one from T to R. That would be a diagonal since it's not a side. So a diagonal is a line segment that joins 2 vertices, but it can't be a side on the diagonal. All right, now, the other thing that we're going to look at today, this is similar to what we looked at on Friday actually, when we talked about triangles. And I told you that the measurement of a triangle always equals 360 degrees, no matter how big or small it is. No matter how big or small it is, angle plus angle plus angle is always, it's 180. Angle plus angle plus angle always equals 180 no matter what. No matter what. Quadrilaterals are the same way. If I added up the angles of the trapezoid, or I added up the angles of the square, or I added up the angles of the parallelogram, or the rhombus, or the rectangle, it doesn't matter what the shape is. Every single time we measure a quadrilateral, angle plus angle plus angle plus angle is always going to equal 360 degrees, no matter what. No matter what the quadrilateral is. Doesn't matter if it's a trapezoid, square, triangle, rectangle, angle plus angle plus angle plus angle is always going to equal 360 degrees. It's the same thing. Since there's 4 angles, you're going to have 4 angles that you're adding. They're going to equal 360 degrees. We're going to do this the exact same way that you did the triangle, though. You're going to fill in the angles that we do have, add them up, subtract from 360 to try to figure out what our missing angle is. So if we take a look here, I have a trapezoid here. I have a trapezoid here. And I have, let me scoot this down. I can see my trapezoid, and I have one angle is 120, one angle is 70, one angle is 60. So I'm going to fill those in. There's my 120 degrees, there's my 70 degrees, there's my 60 degrees. I don't know what the last angle is. We're going to have to figure it out. And we're going to do it the exact same way how we did our triangle. Step 1, we have to add up 120, 70, and 60 and see what we have so far. So if we take a look at step 1, I'm going to add 120, actually I'll just do it. We're going to add up 120, 70, and 60. 0, 0, 0. 6 and 2 is 8, plus 7 is 15. So I have 250 so far. And I know that angle plus angle plus angle plus angle is always going to equal 360. So step 1, I know I always have to add up the angles I already have. If I take a look at step 2, I need to take 360, because that's what it has to equal, and I'm going to subtract 250. When I subtract those, I get 110. So I know my missing angle here, n equals 110 degrees. Angle plus angle plus angle plus angle equals 360 degrees. Step 1, we have to add up the angles that we have. Step 2, we subtract 360 minus the number of angles we have, and that gives us what angle is missing. Now, we're going to go ahead and take a look in your book on page 334. You're going to be doing your assignment right out of your book today. I'm going to erase this so it doesn't show up over your book stuff. But we're going to go ahead and take a look at page 334 today. We're going to take a look at page 334 in your math book. There's the picture that I just showed you in your math notes. It looks the exact same. You're going to use that to help you guys with these first 8. Because on numbers 1 through 8, you're only going to do some of them today. I'm not assigning all of them, just some of them. On number 1 through 8, it asks you to classify it in as many ways as possible. Remember I talked about how some shapes can fall into the definition of another shape, so you're going to list them that way. So all the different ways that we can classify a rectangle on number 1. Obviously rectangle is your first answer because that's what we typically call it. But what other names could we give a rectangle? You'll have 2 answers on that one. I put this on your math sheet so you'll know how many answers for each one. Number 2, it's only going to have 1 answer. Number 3, it's going to have 4 answers. And I kind of helped you guys out with that. Number 4, 1 answer. 5, 1 answer. 6 also has 4 answers. And I would probably take a look at number 3 because it's the same shape. And 7 and 8 are both just going to have 1 answer. So on 1 through 8, you're just going to classify as many ways as possible the shapes that you're seeing. Some of them are going to have more than 1 answer, and I have all of that on your homework sheet for you so you know how many answers you have to have for that part of the assignment. Then you're going to jump all the way over to the next page to 16 through 18. You're going to find the measure of the missing angle. I'll underline that right there. That's exactly what we just did together. And it even gives you an example right above it. Same thing right there. Angle plus angle plus angle equals 360 degrees. Angle plus angle plus angle equals 360 degrees. So you are going to do that same thing. Angle plus angle plus angle plus angle equals 360. You're going to fill in the 3 angles that you already have. You're going to subtract it from 360. That will give you what n equals. So then you have to do 16, 17, 18. So today all you're doing is 1 through 8, classifying, and then 16 through 18, finding the missing angle.